In this video, we're going to continue the notes on section 2.3 by looking at example 3. So in this example, we are asked to find the derivative of the function, period. So we're not finding the derivative of the function at the point, but we're finding the derivative of the function as a function. So what will we hope to find in the end? Well, we'll hope to find what f prime of x is, rather, for any x. So we saw this in example 1 when we used the limit definition of the derivative to find f prime of 2. We found a function, meaning a map or an equation, where we could input any x and we'd output that derivative at the x. So that's a similar or same thing that we want to do here. So we know from the definition of the derivative that f prime of x is equal to the limit as h goes to 0. We're setting up that difference quotient of f of x plus h minus f of x all over h, where for s, f of x is this x squared minus 2. So what we want to do first is compute each of these terms. So this is going to be equal to the limit as h goes to 0 of, so f of x plus h, I need to plug in x plus h to each of the x's in my f of x. So I have x plus h squared minus 2 times x plus h. Now from this, I'm going to subtract f of x. So I'm going to write in my parentheses here so that I get that negative into each term. So f of x is what I get when I just plug in x into my equation. So I'm going to subtract x squared minus 2x. So there's my lovely numerator, and in the denominator, I just have h. So take a moment to pause the video and expand this numerator out as much as you can. Once you're there, then try to simplify. All right, so now let's check answers. So we should be getting the limit as h goes to 0 of x squared plus 2xh plus h squared minus 2x minus 2h minus x squared plus 2x all over h. So after you found that, if you haven't already simplified this numerator, please pause the video and try to simplify as much as you can. All right, and when you're ready, let's compare answers. So what you'll notice is that many things cancel out beautifully here for us. So we have our x cancels with x squared here. And our negative 2x cancels with a plus 2x. So now let's gather the remaining terms in the numerator. So we have the limit as h goes to 0 of 2xh plus h squared minus 2h all over h. And what do we notice in that numerator? There's an h in each term. So we can factor out an h from each term. So we just get h times 2x plus h minus 2 all over h. From here, the h's cancel, and we're left with the limit as h goes to 0 of 2x plus h minus 2. And now there's no issue with just plugging in h equals 0. So we evaluate this limit by doing so. So we get 2x plus 0 minus 2 is equal to just 2x minus 2. So now that we have no more h's in our limit, and we actually don't have the limit anymore, we have found our equation of that derivative. So we just follow back what we just done. We've started with the definition, the limit definition rather, of the derivative f prime of x. And we've expanded, simplified, and in the end get that f prime of x is equal to 2x minus 2. So for any x value you give me, I can plug in that x value. Maybe it's like 11, maybe 111. I can plug in that value into my function for the derivative. And I can tell you what the slope of the tangent line is at that point, at x equals 111 with a funny hat. All right, thanks for watching. Please feel free to review any parts of these videos to help develop and further your understanding.